Welcome to another video with the TI-83 Plus graphing calculator. In this video I'm going to show you how to solve trigonometric equations using the graphing calculator. I need to give you some background. You probably already know this if you're watching this video, but just in case, let me show you this. Let's go over the relationship between a degree and a radian. Here I have a 180 degrees is equal to pi radians. Pi as a number is 3.14. So 180 degrees is equal to pi radians. So if I divide both sides of this equation here by 180, the left side rather becomes 1, and the right side becomes pi radians over 180 degrees. I get this equation here. If I choose to divide both sides of this equation by pi radians, then the right side becomes 1. I put it over here. And the left side, which is right here, is 180 degrees divided by pi radians. Okay, so I use basically these two factors to convert from one measure to the other. So let's suppose I have 90 degrees and I want to convert that to radians. Well, I would start off by saying, well, 90 degrees is the same as 90 degrees times 1. And 1 is equal to this, and 1 is also equal to this. Now, since I want this to be in radians, I choose to multiply by this factor, because now you can see this is degrees here, this is degrees here, the degrees cancel out. 90 into 180 gives me 2, so this reads pi over 2 radians. Or just pi over 2. The radians is what we call a pure unit. You can leave it, or you can leave it out. Okay, so most of the time we just write pi over 2. Instead of saying pi over 2 radians, we just say pi over 2. The radian is understood. Another example, 60 degrees is the same as 60 degrees times 1. Replace the 1 by pi radians over 180. Notice the degrees cancel out. The 60 into 180 goes 3. So this comes out to pi over 3 radians, or I'll just say pi over 3. Now to convert the other way from radians to degrees, I have 2 pi over 3. Write it as 2 pi over 3 times 1. In this case, I replace the 1 by 180 over pi radians. Now notice here, these are radians right here. Those cancel out. The pi and the pi cancel, radians cancel out. 3 into 180 is 60, times 2 is 120. In the same way, pi over 2 is the same thing as pi over 2 times 1. That's equal to pi over 2. Replace the 1 by 180 over pi. The pi radians cancel out. 2 into 180 is 90 degrees. So pi over 2 radians is the same thing as 90 degrees. Notice also, since pi is 180, I could have just replaced the pi here by 180, divided it by 2, and I still get the answer. But sometimes you're not going to have the pi in the number. Okay, so it's best to know these factors right here. Okay, so again, if you're working with angles and you write, say, 2, for example, with no units, that's implied to be 2 radians. If you want degrees, you have to put the degree. Okay, so let's cancel this out now. Maybe go back over here to the main file. So we're going to solve a few examples here. This one says solve each equation over the interval from 0 to 2 pi. Okay. So that means they want the answer, since they have 0 to 2 pi, they want the answer in radians. Sometimes they'll say from 0 to 360. They'll want the answer in degrees. Okay, so this is what I'm going to do. I'm going to set my calculator, turn the calculator on. Set my calculator, okay, look at the mode. It's on radians, and that's what I want. But a lot of times the answer is going to come out exact. So in order to do that, it's easier to work with degrees first and then convert from degrees to radians using the procedure I just went over. So let me just go put this in degrees, hit enter. So now it's in degrees. So now what I'm going to do is I'm going to look at this first equation. 2 sine theta plus 6 is equal to 5. I'm going to find the solutions to these equations using the graph of the function f of x equal to 0, similar to what I did in the last video with logarithmic and exponential equations. So if I bring this 5 over to this side, this reads 2 sine theta plus 1 is equal to 0. So I'm going to graph that function there. Okay, so go hit the y equals, clear this, and let's enter 2 sine, and the variable is theta, but I'm just going to hit it right here, and that's going to give me an x. That's the same thing as a variable, so that's whether it's x or theta, it's the same thing. So close parentheses, and then this is going to become plus 1. So I'm going to graph this. 2 sine theta plus 1. I'm going to hit the graph key. That's what's going to happen with trig functions is you're not going to get a nice graph most of the time unless you go to zoom and use number 7, which is z-trig. So if you're working with trig functions, I recommend you use this graph, the z-trig. So hit 7, and there's the graph. Now everywhere the graph crosses the x-axis, that's an x-intercept, and it also generates a 0 for that particular point. So the solutions are going to be, there's a solution right there where it crosses. Over here it crosses again, and if you keep on going it crosses again. This one again keeps oscillating back and forth. So there's a solution right there, there's a solution right there. So let me point out to you that if a trig equation has one solution, it's going to have an infinite solution, because the solutions keep repeating, because the functions, the trig functions, are periodic. Most of them have a period of 2 pi, 2 of them have a period of pi, so the solutions are going to repeat every 2 pi or pi units. Now in this case we want only solutions starting from 0 to 2 pi, so we don't care about what happens over here, we just want this right here. So what I'm going to do first is hit the trace key. Hit the trace key. And then hit the arrow key here, and we're going to trace the curve. And when you get close to the x-axis, slow down. Okay, notice right there, notice what I have here. This is in degrees, remember, so this is 210 degrees, y is equal to 0. So that's the y-intercept. 210 then is a 0 of this function, which happens to be a solution to the equation. So 210 is a solution to the equation. Okay, so let's keep going. Slow down, notice 330, y equals 0. Okay, 330 is also a solution to the equation, and it falls in this interval from 0 to 2 pi, or in my case, since I'm looking at degrees, from 0 to 360. Now if I keep going, I'm going to get more solutions. But notice, at this point right here, I'm already past the 360, which I'm also past the 2 pi, because 2 pi and 360 are the same. So there's no reason to keep going. The solutions from 0 to 2 pi, or from 0 to 360, are going to be 210 and 330. So if you multiply these two, the 210 by pi over 180, and simplify, that'll give you 7 pi over 6. Okay, and if you multiply the 330 by the same factor of pi over 180, you're going to get 11 pi over 6. So the solution to this equation, in this interval in radians is 7 pi over 6 and 11 pi over 6. If it's asking you for the degrees, of course, it's 210 and 330. Okay, so let's clear this, and let's look at the next one.